So let me ask you something. What if I told you that one of the most common security mechanisms on the internet today is quietly helping attackers get smarter? Not by failing, but by teaching them. Sounds strange, right? Well, that's exactly what's happening. Welcome to Bluehat Cybersec Academy. Today, we're diving into something subtle, powerful, and honestly a bit unsettling. CAPTCHA poisoning, when attackers turn defenses into training data. In the ongoing arms race between defenders and attackers, security mechanisms don't just protect systems anymore, they become targets themselves. And to really understand this, we need to start by understanding CAPTCHA itself as a security layer. CAPTCHAs, short for completely automated public Turing tests to tell computers and humans apart, exist to answer one simple question: is this a human or a machine? To do that, they present challenges that are easy for humans but difficult for bots. Things like distorted text recognition, image classification, like select all squares with traffic lights, behavioral analysis, mouse movement, timing, interaction patterns. Modern CAPTCHAs increasingly rely on AI themselves, especially image-based ones. And that is exactly where the problem begins. What is CAPTCHA poisoning? Because now we arrive at something more interesting. What exactly is CAPTCHA poisoning? CAPTCHA poisoning is the process where attackers collect CAPTCHA challenges, collect the correct answers, and use both as training data. Over time, they build machine learning models that can solve CAPTCHAs automatically with high accuracy. So instead of writing scripts or using simple OCR tricks, they train systems that actually learn. And once that happens, the CAPTCHA stops being a barrier. It becomes a dataset. Now, here is where things get even more important. How does this attack actually work? At a high level, CAPTCHA poisoning follows a loop, a continuous, self-improving cycle. First, data collection. Attackers interact with CAPTCHA systems at scale, gathering massive numbers of challenges. Then, label acquisition. They need correct answers, and they get them through human-solving farms, crowdsourcing platforms, relay attacks where CAPTCHAs are forwarded to real users. Next, dataset construction. Each CAPTCHA becomes a labeled example, an image paired with the correct solution. Then comes model training. Using techniques like convolutional neural networks or transformers, attackers train models to recognize patterns and solve challenges. After that, automation deployment. The trained model is plugged into bots, which now solve CAPTCHAs automatically. And finally, continuous improvement. The system keeps collecting new data, retraining, adapting, and evolving. It never stops learning, which means the defense system is unknowingly helping train the attacker. At this point, you might be wondering, why is this even called poisoning? Now, the term poisoning here is a bit nuanced. In traditional machine learning, data poisoning means injecting bad data into a system to corrupt it. But CAPTCHA poisoning is different. Attackers aren't corrupting the defender's model. They are doing something more subtle. They are using the CAPTCHA system as a data oracle, a source of perfectly labeled training data. And in some advanced cases, they may even try to influence which CAPTCHAs are served or solved, quietly shaping the data they collect. So naturally, the next question is, what is making this so practical in the real world? Several factors have made CAPTCHA poisoning much more viable. First, cheap human labor. CAPTCHA solving services can label huge amounts of data for very little cost. Second, advances in AI. Modern models are extremely good at image recognition, pattern detection. Sequence understanding tasks that used to be human only are no longer out of reach. Third, repetitive challenge pools. Many CAPTCHA systems reuse images or patterns, which allows attackers to memorize, generalize, and improve quickly. And finally, API and automation exposure. If CAPTCHA endpoints aren't properly protected, attackers can request challenges in bulk, which accelerates everything. Now let's talk about impact, because this is where it gets serious. The consequences go far beyond just solving CAPTCHAs. Once that barrier is weakened, a lot of other attacks become easier. Account takeovers become more effective. Credential stuffing can run continuously without human help. Fake account creation scales dramatically. Spam, scraping, and abuse all increase. And perhaps most importantly, it undermines trust in CAPTCHA as a security control. Because if it can be learned, it can be defeated. So the real question becomes, how do we defend against something like this? CAPTCHA poisoning isn't unstoppable, but it does require a shift in thinking. The goal is no longer just to make CAPTCHAs hard, but to make them unlearnable, or at least less valuable as data. One approach is dynamic and diverse challenge pools. The more variation, the harder it is to train reliable models. Another is behavioral analysis. Things like mouse movement, typing rhythm, and interaction timing, signals that are much harder for AI to mimic convincingly. Then there is rate limiting and access control. If attackers can't collect data at scale, their models suffer. Adversarial CAPTCHA design is another layer, introducing subtle distortions that humans ignore, but models struggle with. Also, multi-factor verification. CAPTCHA should never be the only line of defense. It works best when combined with other checks. And finally, monitoring. If solve rates suddenly spike, something has changed, and it needs attention. Now zooming out for a moment, this isn't just about CAPTCHAs anymore. CAPTCHA poisoning is part of a much larger shift. We're no longer dealing with simple bots or static scripts. We're dealing with systems that learn, which creates an environment of AI versus AI. Defenders build smarter CAPTCHAs. Attackers build better solvers. Both sides iterate continuously. And in that kind of landscape, static defenses don't last long. So now, think about this for a second. Every time you solve a CAPTCHA, are you just proving you're human? Or are you unknowingly contributing to training the next generation of bots? At its core, CAPTCHA poisoning reveals something important. Any system exposed to users can become a data source for attackers. CAPTCHAs were designed to block automation, but now they can feed it. So the takeaway is clear. Don't rely on CAPTCHAs alone. Assume attackers are learning from every interaction and design systems that stay resilient even when individual defenses fail. Because as AI keeps evolving, attackers won't just keep up. They'll keep learning, and they'll keep adapting. Now, before you go, let's make this interactive. If you were designing a CAPTCHA system today, how would you prevent attackers from collecting training data at scale? What kind of challenge would be easy for humans but resistant to machine learning? And most importantly, can a CAPTCHA ever truly stay ahead of AI? Think about it. Pause the video if you need to, because these are not just questions. These are real-world problems security engineers are trying to solve right now. And if this made you see CAPTCHAs differently, then you are already thinking like an attacker and a defender. So go ahead. Like the video if it challenged your thinking, share it with someone who still thinks CAPTCHAs are just a checkbox, and subscribe to follow the full journey through advanced hacking, attacks, and exploitation. I'll see you in the next one.